Let me make a couple of more points here about the Arctic before moving on. So this is the observed September ice extent, which has been dropping, but every month it is dropping. This is the March to April snow cover, which is also dropping now since the mid 1970s. So these are the consistent responses to warming that we expect. So even though the time period is relatively short compared to, let's say, the warming over the industry since the Industrial Revolution, we can confidently say that the Arctic ice melt is related to global warming. And now already there have been 2 years when the so-called Northwest Passage opened up, so the Arctic became so ice-free that you could go directly from the North Atlantic through the Arctic into the Pacific through the Bering Strait. That is not good news. Okay. Antarctica is a little bit more complicated story. Why? You can see that here the melt rates of the glaciers, reds are negative, which means the glaciers are losing mass, and the blue colors are where the glaciers are actually gaining mass. So you can see here Ross Sea, Weddell Sea, and the other regions, various glaciers, and the pie charts are showing the melt and calving, or the breaking down of the glacier into pieces. And there is lots of regions where a lot of calving is happening and a lot of melting is happening. And yet, why are there all these blue regions where some glacier mass is accumulating? What does that happen? Why does that happen? If you remember the configuration, there is the Southern Ocean surrounding the Antarctic continent, and the oceans are warming, as we saw before. Southern Ocean is especially warming, and the heating penetrates deeper because it's a channel and the wind-driven currents can go much deeper. Wind energy can be put in much more when there are no boundaries, and it's that warming that's penetrating into the Indian Ocean and the Pacific Ocean. Remember, the Indian Ocean is a very small ocean, so the time scales are relatively fast of the meridional overturning circulation. So the warming of the Southern Ocean actually can make the atmosphere warmer. Why is that critical? Because warmer atmosphere can hold more moisture, which can increase snowfall on some parts of Antarctica. So the warm ocean can also increase calving because the glaciers are like molasses. Remember, they are compressed snow. They can flow. So on the slopes, they flow down onto the ocean and form shelf ice. So these ice shelves that hang out over the ocean waters, they can go up and down, oscillate, and then break off, or they can melt in front of the grounding line where the glacier is anchored and break off. The calving happens because of that. So the waves, the sea level rise, etc., make the ice shelves vulnerable to breaking off, and the warm water under the shelf shelf ice increases the melt rates of these glaciers as well. So long story short, Antarctica is very different because it's surrounded by the ocean. Warm ocean can increase the snowfall rates on Antarctica in some parts and increase the accumulation of glaciers. But the news is not that good, right? Most places are actually losing glaciers, and the ice albedo feedback, as we know, goes much faster. So there have been some huge chunks of glaciers that have broken off, and right, as I mentioned in another podcast, right now in November, early November 2020, there is a massive iceberg that's floating towards, I think, the island of Georgia in the Southern Ocean, Southern Atlantic. Okay, so that's a complicated story. IPCC, the Intergovernmental Panel on Climate Change under the United Nations Framework Convention on Climate Change, UNFCCC, produces these reports every 7 years that we will talk about in a podcast coming up, has collected all the evidence that exists on all continents for changes in physical systems like glaciers, snow, rivers, coastal erosion, and sea level rise effects, and so on and so forth. Biological systems like terrestrial ecosystems, wildfires, marine ecosystems, and so on. And human managed systems like food production, livelihoods, health, labor economics, and so on. And there are these bars associated with each of these. So the colors correspond to physical system, biological system, and human managed systems. And the bars here tell us how much confidence there is in attributing the observed changes to human influence. So the range goes from very low confidence to very high confidence. But the main message I would like you to take out of this is that in every ocean on Earth and every continent on Earth, the biological, physical, and human managed systems have been affected to some extent or the other, with some confidence on or the other, with human impact on them. So climate change caused by human activities have affected the biological, physical, and human managed systems on every continent and in every ocean, from the polar regions, Arctic and Antarctic, to North America, Europe, Asia, Central and South America, Africa, and Australia. So the island states are especially vulnerable to sea level rise. All sorts of issues are arising out of that. Human fingerprints are all over our climate as well. So it's not just the global mean temperature rise. We can look at the cooling of the upper atmosphere. Why? To first order, if greenhouse gases are trapping more of the energy coming from the surface as outgoing long wave radiation, then less energy is coming out into the upper atmosphere. So the upper atmosphere cools. To first order, there's more complicated dynamics. Winters are warming faster than summer because summer is already warm, and when summer warms more, convection happens and energy gets moved, whereas in the winter you can see the warming more clearly. Similarly, nights are warming faster than the days. There is less oxygen in the air because of fossil fuel burning, massive amounts of consumption of oxygen. Less heat is escaping to space, so the radiation imbalance is happening at the top of the atmosphere because greenhouse gases are trapping the energy. More fossil fuel carbon in the air. More heat is returning to Earth because of the greenhouse gas trapping. More fossil fuel carbon in the trees. The C13, C12 shift clearly shows that photosynthesis is now absorbing the air in the atmosphere, which is having more depleted C13, CO2, and that's being taken up by the trees. Amazing, right? How we can do the detective work. Corals are taking up more CO2, fossil fuel CO2 as well, and the patterns of ocean warming that we saw. Okay, so 20th century has clearly recorded the changes associated with human activities dominated by fossil fuel burning, but it also includes land use change like deforestation, urbanization, agricultural lands which do not keep carbon as long because we are constantly harvesting and tilling and replanting crops, so the turnover time is shorter. Albedo is also different. Irrigation is done in large scale, which also affects the air-sea exchange, atmosphere, land exchange of water vapor and energy flux. So all these together add up to very clear signatures on all continents and in all rivers, the impact of climate change.